Hi, welcome to Chemical Bonding Part 3. My name is Dr. English. Specifically, we're going to be talking about how ions are organized in ionic compounds, the physical properties of ionic compounds, and then what is an electrolyte. So, how are ions organized in ionic compounds? Ionic compounds are organized through an ionic crystal lattice, something similar to this one right here. This is a neutral compound, in other words, no net charge, that is composed entirely of ions in a special three-dimensional arrangement. So if we look at this model right here, the green spheres are representing chloride ions, and therefore they will have a negative charge associated with them. The purple spheres represent sodium ions, and they will have a positive charge associated with them. So each sodium ion is surrounded by 6 chloride ions, and at the same time, each chloride ion is surrounded by 6 sodium ions. Ions form a three-dimensional structural arrangement that maximizes the electrical attractions among positive and negative ions. Ionic compounds tend to have high melting points, greater than 300 degrees Celsius. Therefore, ionic bonds in general are quite strong. So here we have a chart of some ionic compounds, their formulas, their melting points, and their boiling points. The higher the melting point and the boiling point, the stronger the ionic bond. Electrostatic forces, which is the force of attraction between that positive and negative ion, are 10 to the 25th times as strong as gravitational forces that we feel here on Earth. In other words, ionic bonds, these electrostatic forces, are really, really strong. Ionic compounds tend to be brittle. They can shatter when struck with a hammer or other blunt object, as we see here with this sodium chloride crystal. If we were to hit it or knock it against the table, it would cleave or shatter into smaller sodium chloride crystals. Ionic compounds in general can dissolve in water. The ionic bonds will break and the ions will separate off the solid crystal and float freely in the aqueous solution. Remember, aqueous, think aqua, aqua, think water. So water solutions. Now let's look at this simulation. We have free floating water molecules. We have added sodium chloride. And what we see here is the sodium chloride will break into individual ions. Each sodium ion is surrounded by water molecules with the slightly negative end facing the positive ion. Same thing here with the chloride ion. In general, water molecules which are neutral will have their slightly positive ends of the molecule facing towards the chloride ion. Ionic compounds are good conductors of electricity when dissolved in aqueous or water solutions. Only when an ionic solid is dissolved into its component ions or melted can these substances conduct electricity. In this situation, electrons will be able to move from ion to ion. Ions in solution that conduct electricity are called electrolytes, any charged particles in an aqueous solution. So here we have a little simulation where we're going to put a conductivity tester in water, and initially the light bulb is not lit. As soon as we add the salt will break down into ions, and we can see that the bulb grows brighter and brighter because the electrons are able to move from ion to ion, therefore lighting up the light bulb. Ionic compounds are not good conductors of electricity in the solid form, where they represent a crystal lattice, because remember, in the solid crystal structure, the ions are in a fixed position and electrons cannot flow. In other words, electrons cannot move. If they can't move, they can't conduct electricity. So what did you learn? We went over how ions are organized in ionic compounds. We talked about the physical properties of ionic compounds, and we discussed what is an electrolyte. Need more help? Feel free to contact me. Have a great day.